All right, well, welcome to class, and thanks for coming. Do you have any questions on the homework? Hearing none, let's take this quiz here. I'll give you 5 seconds to do this quiz. Just want to make it sound like I'm starting from scratch. Okay, so let's go over the answers to the quiz. Here we are. This I've color-coded what I did. So I know that probably made it even worse. There's so many digits there. But so the 2 here is all by itself. 1, that's 1 times 3, 0 times 9. This is 3 cubed, 27. And then that's 3 to the 4th, 3 to the 5th, 3 to the 6th. And then I did it, like I said, I just added it up in my head. You'll have to let me know. I'll be shocked if I'm right. So was it 1193? Wow, my mental calculator is still working. I don't have dementia yet. So it's always good to know that. Well, let's do the next one. You know, it's a concern at my age. Come on. You know, like I do my crossword puzzles. I keep up with the Wordle every day to make sure that I keep my brain active. Sure, yeah, I'll do Wordle. You want to do it? Oh, yeah, so give this one a go here. You can't do this one? Wait a minute, did I not change anything from the... Well, it doesn't matter. It's good. It's good. Yeah, a lot of people blew this on the quiz last time, so this will be a good quiz for everyone since everyone's going to get 100. All right, let's see how you did. I know I'm not giving you any time, but don't worry, you're gonna get it all right. So when I look at a Roman numeral, I generally sort of in my mind I break it up into little chunks that represent the digits, like the MMM, that's 3,000. So I'll just put that down, 3,000. That there is 90, and this here is just 8. So this will be 3098. Will be the final answer. But there is some logic to what you can put before. Like someone said, why can't we just do this for 999? And the reason is that if you look at this table here, the things that are close to one another, those are the things you can sort of write in reverse order. For example, you can put the 1 before a V and an X, but you can't put the 1 before an L. Same thing goes with the X. The X can go before the L and the C. So XL is 40, XC is 90, but you can't do XD for 490, even though it makes sense logically, doesn't it? But they'd say, no, we're not going that far. And same thing with the C. The C goes before the D and the M to make 400 and 900. So anyway, there's the answer there. You'll have this by the time you get to the exam, you'll be fine. So did everyone get it right? You did good. So I guess I can just mark you all down for 100% in the grade book for this one. Quiz 2, there it is. I was talking with my colleague. I think I mentioned this, that I have a colleague who forced me to use this system, this Lumen, and she will deny it. She'll say, no, you could have chosen whatever you wanted. And I guess that may be true, but I still did whatever she did. Anyway, I was talking with her and I said, where is this one topic that I really like? Because I like this topic, not this one in particular. I don't really like this topic, to be honest. And she said, it doesn't exist in Lumen. I said, what? I was so sad. So I did some digging and I found it. So I'm very excited. But in the digging, I also found some topics that I was disappointed with. Like, I never start out a class with Roman numerals and Kipu and that. I always started at Egyptian numerals. So we're going back. We're going back to the Egyptians, and we're going to learn how to count like an Egyptian. Just like what was this song? Count like an Egyptian. Yeah, it goes. That's how it goes, right? Count like an Egyptian. 2 like this. Do this. Okay. Anyway, so we're going to do the Egyptians and the Babylonians. If we don't get to Babylonians today, I'm fine. I'm okay with it. In fact, I'll be thrilled. In fact, I'd like to actually skip the Babylonians and go on to the Time Lords just because that seems exciting. So we're going to go to Egyptians, though, first and deal with the Egyptian numerals. And then if we get to the Babylonians, that's great. But if we don't, that's fine too, because we've already wasted all sorts. No, not wasted. We have enjoyed the last 20 minutes, haven't we? Okay, Egyptian numerals. So the Egyptians, they counted using this system that was completely pictorial. So you've probably heard of the hieroglyphics, right? And the what is it called? Not the Rhind papyrus, although we do talk about the Rhind papyrus here. There's another one, Rosetta Stone, the Rosetta Stone, right? That's how we were, Westerners were able to decipher the Egyptian hieroglyphics.
I don't know if I'm getting this right, but the Rosetta Stone, in case you didn't know, was a stone written by priests to, I think it was a thank you card, basically, an ancient thank you card. That's what I've read.
Sounds good to me.
Yeah.
And
it's what we translated the ancient Egyptian language out of.
Okay, excellent. Thank you. So yeah, well, that's good enough. I mean, what made it so special is that it was written in 3 different languages, so that you had like you could I forget what the 3 languages were, but one of them was Egyptian hieroglyphics, and then there was one Sanskrit or something. But anyway, that way we could like make a connection between the 3 and say, wait a minute, I think that symbol means this, and here's this. So it really helped us decipher. However, we're interested in the numerals, the numbers. The numbers come from a document that was found called the Rhind papyrus. In the Rhind papyrus, it looks like this. This is sort of an image of it. It was just a math book. Isn't that cool? That we have a math book from ancient Egypt called the Rhind papyrus, written by a scribe named Ames. And it just was a bunch of problems. You know how math books are? Basically just a bunch of problems that you have to try. So, but it illustrated the additive number system. You can't tell because this is all pixelated, but these are various pictures. So I have stylized versions of the numbers, and you'll see these versions on the maybe not in the text, but on the homework for Monday for sure. So, so here they are. So hieroglyphics, the Egyptian number system, it was an additive system. I keep saying that, but I keep not explaining what I mean by that. Well, we'll get to it, don't worry. Basically, they had these symbols for each of the powers of 10. So they used a base 10 system of sorts, but it wasn't the same as ours. And there's a big problem that occurs when you don't use a positional number system that we'll get into. But here you have the Egyptian and the Hindu-Arabic numbers. So when Egyptian wrote something that looked like that, it was a 1. This is supposed to be a heel bone. And so that was a 10. I think I drew some of these for you the other day, but now you can see them at least in sort of the stylized form. The coil of rope is 100. The lotus flower is 1,000. That thing that looks like a hot dog is actually a finger. That's supposed to be 10,000. The fish, I forget what, or guppy, I think it is, whatever it is. It's 100,000. And then depending on what book you look at, that's either called the astonished person or the sun god Ra. So either way you cut it, it's the biggest number, 1 million. By the way, the Bible refers to Egyptian numeration, maybe not directly, but in Genesis, we're told that Joseph gathered up so much grain that it could not be numbered, that it couldn't be counted. And the only reason that I can imagine that you would say that is if you gather up enough grain that you run out of numbers, like the Egyptians, you wouldn't, even if you measure it in bushels, if you have more than, say, 10 million bushels, whatever it is, you're going to run out of numbers eventually because this is the biggest symbol that they had. You could draw 10 of these little guys, then maybe 11, and then after a while you're like, good enough. We have lots of grain. It's without number. So anyway, just a little interesting aside. Next time you're reading Genesis about the story of Joseph, you can think about Egyptian hieroglyphics. Anyway, so what does it mean to be additive? It means that to make a number, you just smash together all the symbols for whatever number that you want. For example, let us do the number 1968. which is the year that I was born. I always see, I see the sweatshirts, like the day one. This is 27 years ago when I started teaching here. I saw kids, 1968 emblazoned on their sweatshirt. And I'm like, what? You know, because all I thought of was 1968. That's when I was born. But anyway, it's also when this college was, or university started. Anyway, getting back to this, 1968, the birth year of MVNU. Let's make this, we're going to have one lotus flower for the 1000. And unlike the Romans, there's no subtraction here. So you want to write 900, you just put 9 coils of rope. 2, 3, 4, 5, 6, 7, 8, 9. You know, you can make a picture out of it, I guess. You could put a bunch of coils of rope. It was a pictograph or pictogram. So this is kind of a boring way of doing it, but you might be able to make a little pretty picture out of this. There's 1960. I need 6 heel bones. Those are oxen heel bones, supposedly. So there's 6 of them, and then I need 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. I'm done. 1968. I know, it's kind of hard to read, though, isn't it? You have to really think about it. So you can appreciate, hopefully, our number system because of this. So notice that it doesn't matter what order they're in. Generally, I will put them in order from biggest to smallest, but they could be in any order you want. You know, this still means 1,968. That's what that means. Okay, so that's what it means to be additive. You're just adding up the numbers. Here's a couple of examples. So we convert this to Hindu Arabic. Why isn't this building for me? Do these build? No, they don't. Drat. Okay, maybe I can fix this on the fly. So let's take a look at this one. You've got the astonished man. That's 1 million. Then the fish or the guppy is 100,000. A couple lotus flowers for 2,000. 300 for the 3. Yeah, 3 coils of rope. And then now I'm not looking at it anymore. The 4 heel bones and the 6 lines. Just a sec. I'm going to fix this so that it'll work better for me. Anyway, you can add those up and you actually get the total that I have up there. Okay, the next one. Give me a sec. That's not what I want to do. I want to do this. Wait a minute. Is this just a picture? Oh, I see. Darn. I see why. Okay, I'll make it work though. Give me a sec. This is my dedication. Well, actually, if I was truly dedicated, I would have done this morning. I just didn't realize it. Okay, here we go. Let's see, why is it not updating up here? There it is. Okay, it updated. I put a big blue box in front of it. Okay, so I want you to convert this. Wait, is that the same? That's the same number. Well, that was all for nothing. Let me move this over to the next one. Give me a sec. Yeah, this will be fun. Okay, so the next one you can do. Oh, this one builds. Now I've got the big blue box for nothing. Okay, that's fine. So convert 192,344 to Egyptian hieroglyphics. Okay, I know. You don't have these memorized. So why don't you write down the Hindu Arabic? Write down the Hindu Arabic, and then I will show you the table that we had earlier. So jot down that number. Give you another 30 seconds here, 15 seconds maybe. Okay, everyone's got that jotted down? 192,344. And then we go back here, and there's the symbols. I'll just write the number though. 192,344. Was that what I had? Yeah, so see how you do with that. All right, let's see how we did. Oh, look at this. I'm just standing here hoping for the best. Just a minute. It'll take me a sec to find your names. This app, sorry, the app that I use is called Pick Me, as if you really want to be picked. Okay, I know. All right, it's just funny to me. I used to use one that was called Random Student, but they every time they update, it messes up something, and now it's no good anymore. Now it's Pick Me. Okay, Pick Me. Gracie, Gracie, this the one there, that one out front. How would I represent that? Yeah, so we're going to use a fish for that. So let's see. I'll draw something. Yours may not look exactly like mine, so I'm going to put a fish here. Very nice. Okay, who's next? Lily? Wait, Lily? Lily Small? Lillian? Why does it say Lily on my phone? Okay. It's just weird that it says Lily. Well, anyway, Lillian. What about the 9 there? What do you do for the 9? Yeah, 9 of the hot dogs or fingers. Let me put them down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're moving on. Uh, what in the world? Allie? Allie? Is there an Allie? You're Allison, but you're Allie. So same thing. My phone knows what you want to be. How does? What is up with? You go by Allison now. I wonder if I can fix that on here. Okay, but anyway, Allison. Allison, what about the 2 there? What do I do? Yeah, the little flowers. We'll put a couple of flowers on here. What's wrong with your sausages? It's hilarious. Delicious. Now I'm getting hungry. I want to go home for dinner. Where are we? Samantha? Why can't I remember people's names? Oh, there's no Samantha, right? Oh, Samantha's skipping. Okay. But oh, and Isaiah's skipping as well. Alize. Is that right? Alize? Alize. All right, what do you got for the 3 there? Swirls. Sure. Here we go. 1, 2, 3. Almost there. So we got, I know, this is so slow. 4. So Adele, the first of the 2 4s. What do you got for that? The upside down U's? Okay, very good. So 1, 2, 3, 4. Almost done. One more thing. And who gets to do it? Looks like Nick does. Nick? What?
Who have those lines?
Just lines, yeah, 4 lines. So 1, 2, 3, 4. I don't know if this is, but when I was doing this, all I could think of was Lord of the Rings, where you've got Frodo with 9 fingers, and they're walking through Mordor. They have 1 fish left. There's a couple of flowers, but nothing really living there. And there's like lots of rope because they have to climb in and out. A lot of dead animals with heel bones of oxen. I don't know what the lines stand for, but anyway, there you go. Egyptian hieroglyphics. Um, so why are the Egyptians not as mathematically as sophisticated as the Babylonians? Well, we haven't gotten to Babylonians yet, but let me try this on you. If we want to add 2 numbers together, how do we do it? Let me go ahead and do this. 335 and 82. Let's add those. So I want to add these together. How do I do it? Just go ahead and add straight down, right? So 5 plus 2 is 7. 3 plus 8 is 11. I got lucky, didn't I? Because if there was another place, what would happen to that 11?
You'd carry the 1.
Carry a 10 actually. But yes, you would carry, I know, we always say carry a 1, but we're really carrying a 10. The 10 goes up to the next column. And so Yeah, so we have a system. We're able to deal with when you have to carry and so forth. What about multiplying? Multiplying is much more complicated. And I'm curious if any of you learned to multiply. I know that sounds so condescending, but I'm so curious maybe how you learned to multiply. How did you learn to multiply? You want to tell me, Sam, don't you?
Sure, yeah.
How did you learn to multiply?
We learned with the multiplication table or whatever. The thing where you make the, well, if it's two numbers, it's a box with four boxes in it. And
Oh, a box.
yeah,
This is so exciting to me. Four boxes.
yeah.
Go ahead.
And so if it's 35, on top it would do 30 in the first box, or not inside the first box, but on the outside, like on top. Yeah, like that, and then it'd be 5 on the one next to it, and then it would be 80 on the side, and then on the bottom would be 2, and then we just multiply the 2.
Hold on. I gotta do this. This is very exciting. Like this.
Yeah,
60.
or it wouldn't be 400. It would be like just 4. No, you're right. Never mind. Sorry.
Wait, are you trying to correct a mathematician?
No.
I have my badge I can show you. Okay. All right, so we're good with this? That's fascinating. I love this because this is not at all. The reason I'm so excited, because I never learned to do this. Here, I did it a much more complicated way. So you want to know how I did it? I did 2 times 5 is 10, but I got to carry a 1. And then 2 times 3 is 6, and then I take that 1, and it becomes 7. 8 times 5 is 40. 8 times 3 is 24, plus 4 is 28. So 2870. This seems way more easy. That's the way you learned it? The columns? I like the SAM method. Does anyone else use something similar or anything different than either of these? I mean, there's probably some, I have seen this before. I've seen it done with triangles instead of squares. I know, you're like, well, if you just take your box and divide it into triangles, there's,
you can do the dot or the parentheses one too.
What?
What?
What is that?
Oh, two parentheses. Put another number inside the parentheses. Like have them next to each other.
Hold on a minute.
Unless you know what I'm talking about.
35 dot, and then what do I do? But then how do I actually tell this without using my calculator what the answer is? Okay, so that's symbolically how you write it, but I mean how to execute it, how to do it. This is sometimes referred to, this method here, I've seen it similar to this, not exactly, I like that a lot. But anyway, this is sometimes referred to as the Russian peasant method. I know. Why would it be called such a thing? But it's because, like, us Europeans, we're all about, like, let's do it this way. And then all of a sudden, someone was, like, wandering around Russia in the early part of the 20th century and be like, well, that's so much easier. So anyway, I don't remember all the history of this, but yeah, it's only in recent years, like the past decade or two. I know that's like your entire lives, but still, this is what a lot of schools have turned to this. Now, the reason I'm doing this is not to, oh, you've got another method?
No.
You have another one?
Yeah, if you did Japanese multiplication.
Tell.
Okay. It's a lot of lines. I used to know how to do it, but I just looked it up again.
Oh, it's
So
lines?
it's like 3 columns, okay? So you
Wait,
have
I'm doing this multiplication right here?
Sure. Yeah, and you have your hundreds, tens, and ones in that order.
Okay. Hundos, tens, ones.
Okay, and then, so for this one, you would do, so the first number is 3, because we start with the 3 in the tens place on the first number, right?
So I put a 3 here?
Well, no, you put a line. You put a line from the tens to the hundreds.
Oh, no. This sounds complicated.
It kind of is.
Okay, I put a line.
Yeah, from the tens going into the hundreds. So you put a line at an angle from the tens to the hundreds.
Starting at the word tens.
Yeah, start at tens where you were, and then go to like the bottom of the hundreds.
All right, we may have to do this. Okay, so right, like.
Yeah, that's good. And then the next number in 35 is the 5, and that starts in the ones, so you go from the ones to the tens now. Yeah. But because I messed this up. So because there's 3, because the other one is 3, you need 3 lines.
Oh, I've seen this before. This is very exciting
Now
as well.
you have 5 lines from ones to tens.
1, 2. Yeah, I've seen this before. 5.
Yeah.
And then
for 82, you go from the hundreds to the tens.
Mm-hmm. Okay.
You do 8 lines.
Yeah, and it's going to get really messy.
Yeah.
Okay, yeah, I've seen this before.
Yeah,
and it's where how many places they cross.
Yeah, how many times they intersect.
Yeah, that's going to take forever. So, but yes, it's super cool though. That's super cool. That's a different. You didn't learn that in elementary school, though, did you?
I learned that in middle school. Yeah.
What? Wait, but it wasn't the first thing that you learned to multiply. Yeah. So I'm saying the very first way that like Westerners, I know I'm so Western Europeans, like okay, so Americans, I don't know, I'm gonna get myself in trouble. Don't send me to the civil rights office, please. Okay. Anyway, multiplication. Oh, my whole point of this is that we use the Hindu. Okay, let's get back to the Hindus and the Arabs. Okay, Hindu Arabic. We use Hindu Arabic, which is base 10, and that allows us to group things into tens. So I love Sam's method because you have it. These are the tens. These are the ones, the units, and these are the tens. These are the units. If you do it the way I learned it as a kid, then you have something similar. You have the units and the tens, so they're grouped up. Now, when you multiply, you actually are saying, well, we have to have memorized, I guess, some multiplication table. 3 times 8 is 24, and then you have those 2 extra zeros there. 5 times 8 is 40. You have another 0 there, and so forth. But it's pretty sophisticated, I guess, is what I'm trying to point out. And it really relies on the fact that you have places. Even this craziness here relies on places because you have these lines, and those lines represent the number of tens, number of ones. And when you have the other lines, I know it's hard to imagine, but these other lines that cross these lines, those lines will show that, well, we need so many tens and so many ones in the new number based on the number of crossings. But it's all about the places. The Egyptians did not have place values. They didn't have places. So they could add just fine. In fact, here, let me show you addition in, where is it? There it is. Give me a sec here. So go back to the Rind Papyrus. Let me show you some addition. Addition would look something like this. Let's say I want to add 32. What were the two numbers? Just a minute. 35 and 82. I'll just erase some of this. We'll do it right here. So we'll do both of these things right here. This is going to be amazing. Okay, we're going to do this like Egyptians, though. Okay, so adding like an Egyptian looks like this. Heel bone, heel bone, heel bone. Line, 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 line. We have that number, and then we have this number. Heel bone, 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 line, line. Now, to add those together, you just draw a box around them, right? It's an additive system. Now, there is a little bit of cleanup you might want to do because you have more than 10 heel bones. So maybe you could take 10 heel bones and turn them into a coil of rope. But that's it. Addition is super easy in Egyptian. Just put a box around it. You're done. Let me just clean it up, though. We'll do the coil of rope for 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's one of them left. And then what is this? 7? 7 lines. 1, 2, 3, 4, 5, 6, 7. So there it is in Egyptian. Now consider how this is going to be a problem when we get to multiplication. Let me write that down in Egyptian. Uh-oh. I went too far, didn't I? Let's get rid of one of those. Okay, that's better. And then 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to multiply those together. But remember that the Egyptians had no concept of a place value. They didn't think in terms of hundreds, thousands, 10,000s, those places. I know they had the symbols, but they didn't think in those terms. So they couldn't do multiplication the way we did, but they had a workaround. And interestingly, the workaround that they use is something that keeps our like cell phones secure, amazingly. I know, you would think, how could something the Egyptians did help us with our like security, like cybersecurity? But it does. I might get to that today, but at least I want to show you how the Egyptians multiplied. Yeah, what do you think?
This is probably not related, but there's also another example of how ancient cultures have influenced modern technology. So Bluetooth is actually named after a Viking king of Denmark,
Okay,
Earl Bluetooth.
so that's interesting.
Yeah, I'm sorry.
No, it's fine. It's a little historical factoid. Okay, so let's actually do this multiplication. So the way that we're going to do it is we're going to repeatedly add. So here's how this works is I've got to get 35 of these. So remember 35 times 82, what that means is you have 35 82s. So I've got a bunch of 82s here like this. 82, 82, 82, 82, etc. There's 35 of them. There's 35 of these. Okay, that we're going to add up. We're going to add them all up. So that's basically what's going to happen. But we don't want to have to sit there and add up 35 of these things. And so a much easier way is to do it this way. Here, watch this. So this is super cool. You know what? I'm sick of drawing heel bones, if it's okay. I'm just going to do this using our numbers, but bear in mind, pretend that what I've done is I've written 82 in Egyptian over here. All right. So anyway, so I can easily double this, right? You can do 82 plus 82. What is 82 plus 82? Do you guys know? 164. Oh yeah, you're quick. 164. And the Egyptians would have been able to do that as well. They'd be like, yeah, coil of rope, 6 of the heel bones, and then 4 of the lines. But I'll just do it in, so this is going to be 164. And then once I have 164, that's an easy number to double as well, right? We can do 164 times 2 is what, 328? Yeah, 328. Gets a little bit harder now, but not terrible. So what's next? 656? Wow, see, even without a calculator, it's not bad. Let's do it. Let's do at least 2 more times because this is kind of fun, isn't it? Okay, maybe not for you, but for me. So double that. Keep doubling.
1312.
Yeah, I think it's 1312 because 650 times 2 is 1300. And then you have the 6 times 2. So far, so good? One more time, and then I promise I'll stop. Wait, what?
2624.
Wow, that was quick. 2624. Okay, so notice what I've done is this one, the very top one, this is 82 times 1. This is 82 times 2. This is 82 times 4. That is 82 times 8. This is 82 times 16, because I'm just doubling it each time. This is all mathematically correct. 82 times 32. What's my goal? My goal is 82 times 35. I'm pretty close to my goal right now. Should we just call it a day? No. We can't call it a day because we're almost there. We have 82 times 32. We want 82 times 35. Where am I going to get 3 more 82s? Add 3 more 82? Sure. Well, there's 2 of them right there. And then 1 right there. So I could just add these together. Now that I've got this chart, I could just say, hey, I'm going to take this. There's 32 of them. That makes 34 of them. And that makes the total of 35 of them. So let's add those up. And we get 2624 plus 164 plus 82, which is a big number. But notice that I did that without using multiplication. I only used addition because 82 plus 82, then 164 plus 164, and so on. That's the way Egyptians did multiplication, is they just kept adding up until they had a table like this, doubling, 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 and then they were able to pull from their table the numbers they needed to make whatever it was that they were looking for. So I don't know, I can find that fascinating. You might wonder, how does this relate to this? Well, our cell phones or our security systems use these cryptography techniques that involve powers of numbers. Like you take something like this, 15 to the 1009, or I don't know. There, let's just say that's the number. And this takes a long time to compute. To compute this takes a long time, even for a computer. Now, by a long time, I mean it might be half a second rather than milliseconds. And so, using sort of a similar idea, you break up this. We're not going to do this now, but using a similar idea, you break this up into different little chunks, and then combine the final answers to get the answer that you're looking for. So it's just fascinating that what the Egyptians did shows up again later on nowadays. Okay, we don't have time for the Babylonians, but we do have time to talk about Time Lords. And so let us do this. I want you to help me out with some calculations, because you're all Time Lords. You know how to do time. My wife and I will usually pick out a movie to watch on Friday night or Saturday night, and we'll just vegetate, especially on Friday night when we're all tired. And so we'll look at the movies, and she'll ask me, how long's that movie? And I'll say, well, it's 126 minutes. And she'll say, oh, too long. And then I'll say, oh, well, this one's 91 minutes. Oh, it's perfect. Like she's more interested in how long the movie is rather than how good it is. So, but you're familiar with these calculations, aren't you? If I said that a particular movie was 126 minutes, how many hours is that?
2 hours.
What? That was so quick. Okay, just a minute. I got to make this harder on you. 6 minutes. We'll do that. 2 hours and 6 minutes. Okay, let's try again. Let's say that, I know, some of these movies like Lord of the Rings, weren't there some movies that were like
The New Justice League is about 4 hours long.
209 minutes long. Yeah, that's going to be harder. No one knows how long that is.
3 hours.
What? 3 hours? You're right. And 21 minutes.
I got that.
Okay. Let's make it harder. What if, I'm going to pick a nice round number. Let's say I do 1,000 seconds. Well, oftentimes, not oftentimes, but sometimes when I'm running a computer program, like in Python or something on my computer, it'll tell me how many seconds have elapsed, and it'll rack up to like 13,000, 15,000. Actually, this isn't big enough. You're right. This is dumb. Let's make it 10,000 seconds. That's more like it. How many hours, how many minutes, and how many seconds is that? I think you can do this. Work with a friend. You can do this.
So 1 minute.
I'm a graphic design major. I don't even know how to do this.
What? Did I just hear a bad statement back there? Who's the graphic design major? I will find reasons. Now you have challenged me. I will go talk to is it Dr. Elopapa? Or is it Professor? Margaret. You just call her Margaret. You guys are so loose down there. Okay. Anyway, I will find reasons, but I can come up. I'll come up with some reasons for you. Don't worry.
He said you go.
All right, I won't pick anyone out of the crowd, but does anyone have any ideas where we're going to start with this, or got an idea for the answer or anything like that? You got something?
Oh, I've got an answer.
Whoa! Let's hear it.
2 hours, 46 minutes, and 40 seconds.
Unbelievable. That's so great. Okay. I got to know what you did. How'd you do it?
I'm going to be completely honest. I Googled it.
Okay, no, there it is. The Google works. Okay, but Adele wants to one up you. Adele?
I got it by doing math.
That's the right way to do it.
I took 10,000 and I divided it by 60 twice to get
Uh-huh.
the hours, and I got like 2.7.
Yeah.
So then I took 2, which I knew the hours, and multiplied it by 60 twice to get the
7,200.
that was, yeah, and then I subtracted that from the 10,000, and then I did that again.
But with 60.
800, and divided that by 60 to get the minutes, which I got 46 point something.
Yeah.
And then I multiplied that by 60, subtracted 800, ended up getting 2,760. And you subtract that from 2,800 to 40.
That's beautiful. I love it. Perfect. You got it. You're a time lord.
Yeah.
So did anyone do it? I know it's kind of hard to maybe for some of you to follow exactly what Adele was talking about, but I totally understood it. But does anyone have a different method that they think they might have done it differently? There's a couple ways of doing this. It's totally okay. So, but you know that you're going to group these into groups of 60, right? Grouping into groups of 60 and then 3,600 because there's 3,600 seconds in an hour and so on. So the true time lords are actually the Babylonians. Because if you can understand our system of time, that clock back there, the clock that you're looking at saying, when will he ever be done? That came from the Babylonians. The Babylonians counted using 60s, not 10s. They thought 60 was important. In fact, our angle measurement came from Babylonians as well. They were far more sophisticated mathematically than the Egyptians. And I guess we'll talk about them on Monday. The homework is all about the Egyptians. I think you'll be okay. But if you do have trouble, send me an email so I know and I can fix things. All right, hope you have a great weekend. Look at this. The little sibs are going to love this. All right.
That's why I want to leave early.